Hi folks, today we're going to begin our journey on solving equations and more specifically linear equations in one variable in our algebra class. And so today's lesson is all related to the learning target that I can solve a one-step equation. Before we actually jump into all the solving though, we need to first understand what it actually means to solve an equation. And let's remind ourselves that to solve means that we're going to be finding the value of the variable which makes the equation true. So we're going to be looking at an equation. Remember, equations are math statements that say that one expression is equal in value to the other expression or to another expression. And most often is the case in an algebraic expression where there's going to be a variable or a letter to represent some unknown number. As we're solving, what we're doing is we are finding the value of that unknown number, which makes the equation true. We've taken some time to lay the foundations for solving equations by talking about two things. Remember, we talked about the properties of equality, and those were the four basic properties of equality, like the addition property, subtraction property, multiplication property, and division property. And remember that the properties of equality simply state that in order to maintain a balance in the equation, what you do to one side of the equation, you have to do to the other. So if you're going to add on one side, you have to add the same value on the other. Subtract on both sides, multiply on both sides, or divide on both sides. Those are the properties of equality. And how do we know which property of equality we're going to use when we solve an equation? Well, remember that what we're trying to do is essentially isolate the variable. And there are numbers that are connected to that variable by some operation, either addition, subtraction, multiplication, or division. And our job when we're isolating that variable is to try to break that connection apart, to undo those operations so that they can move and start clearing themselves from that side of the equation with the variable. I think it's always best to take a look at a few examples, and we're going to take a look at how each of these properties of equality are used to solve an equation, but we're also going to be looking at one specific example which utilizes a little bit more of our concentration and a little bit more effort. So let's do a couple basic equations first. All right. So the question, I'm just going to mark this off. I'm going to say, okay, these are our examples. Okay. And number one, our equation is y plus 6 equals negative 4. Let me zoom up on that. Okay, so remember, what we do to one side, we have to do to the other. But what are we going to do to each side of the equation? Well, the first thing that I would recommend doing is making an observation about what operation you see in the equation. Do you see addition, subtraction, multiplication, or division? And we're specifically going to look at the side of the equation that has the variable. So on the left side of this equation, I see addition. There is a 6 being added to a y. So if I want to isolate y, I need to undo that addition with the inverse operation to addition, which is subtraction. I'm going to use the subtraction property of equality. So I'm going to write the SPE, the subtraction property of equality, in order to solve this. So what does that look like? Well, if I'm adding 6 into y, to undo that, I need to subtract 6. And I'm going to subtract 6 from both sides of the equation. And when I say both sides, what I mean is both sides of the equal sign, right? The equal sign divides our equation into two sides. And what you do to one side of the equal sign, you have to do to the other. What happens when I subtract 6 from both sides? Well, the numbers I see here are additive inverses, positive 6 and negative 6. So when we combine them together, they go away. They become 0, and that's exactly what we want. We want them to disappear. So the only thing left on that side of the equal sign is the y. So y is going to be equal to, now if we combine negative 4 and negative 6 together, we get negative 10. So the value of y is equal to negative 10. We can simply check to see if this is the right solution by substituting that negative 10 back into the original equation for y and seeing if the equation is true. So instead of saying y plus 6, we're going to say negative 10 plus 6 equals negative 4. And is negative 10 plus 6 equal to negative 4? Sure. Negative 10 plus 6 is negative 4, so negative 4 is equal to negative 4, which means that I found the right solution. So again, I used the subtraction property of equality here in order to undo the plus 6 to solve for y. Now, I'm going to ask you to show your work, because the work that you show, or the math that you show, or the algebra that you show, is the evidence for your solving. So you have a claim. Your solution is your claim. The solution is y equals negative 10. The evidence that you provide me is showing your work. The math is the evidence. So please make sure you show that math work. Let's try a few more. Y minus 8 equals 3. So again, what operation do we see? We see subtraction. How do we undo subtraction? We undo subtraction with addition. So I'm going to add 8 to both sides of my equation. And when I add 8 to both sides, negative 8 plus 8 is going to go away. And I'm left with y is equal to 3 plus 8, which is 11. We can check that if we want. If we put 11 back in for y, do we get a true statement? Is 11 minus 8 equal to 3? Yes, it is. So in this case, what property of equality did we use to solve? We used the addition property because we added the same thing to both sides. Let's take a look at the other properties of equality. How about number 3? Number 3 is negative 5x equals 17. Negative 5x equals 17. Now be careful here. I know as you're looking at this, you see that minus sign or that negative sign, and you think that that's actually subtraction. But is it? Are we subtracting 5 from x? Nope. That negative goes with that 5. And negative 5x means negative 5 times x. So the number that's being held to the x is negative 5, and the operation that's holding them together is multiplication. How do we undo multiplication? We undo multiplication with division. So we're going to use the division property of equality to solve this equation. And the division property says that what we divide on one side, we have to divide on the other. What number is connected to the x? Negative 5. So we're going to divide both sides by negative 5. Now, why are we dividing by negative 5? So that when we multiply something by negative 5 and divide something by negative 5, which is what's going on the left side there, they undo each other and the negative 5s actually cancel out. And when negative 5s cancel out, that leaves me with just x. And so x is going to be equal to 17 divided by negative 5. If you want to change that to a decimal at this point, you can. That would be negative 3.4. But what's nice about the division property is that you can leave the division as a fraction. So if you see 17 divided by negative 5, you can leave that at the fraction negative 17 fifths. And I'd be perfectly happy with that as a solution. That is how we use the division property of equality to solve an equation. Last one, here's one last example. We have y divided by negative 7 is equal to negative 6. All right, so what operation do you see? Do you see the division? Y divided by negative 7? How do we undo multiplication? How do we undo division? Oh, I answered the question. With multiplication. So if we are dividing by negative 7, to undo that, we're going to multiply by negative 7. See that little dot I put there? That's showing the multiplication. Remember, we don't want to use an x to indicate multiplication anymore, because now we're solving equations and the variable might be x, and we don't want to confuse our variable x with our operation x for multiplication. So we're going to start using either parentheses or the little multiplication dot to indicate that we're multiplying. So now that we've multiplied both sides by -7, remember, when we multiply and divide by the same number, they're going to cancel each other out. So those -7s cancel, and I am left with just y on this side, and then I have -6 times -7, and a negative times a negative is a positive, and 6 times 7 is 42. So y is equal to 42. So these 4 examples show you how, and let me just write this down. The last one we used the multiplication property of equality because we multiplied on both sides. But these 4 examples show you how those 4 properties of equality are used to solve an equation. I did say that we were going to look at one more example, and it's an example that's going to require maybe a little bit more thought, only because we have lots of different options as far as how to solve it. One of those options might seem more intuitive to you, and I just want you to choose the best option for you and actually use that. And the special case that I want to look at are when we have a fractional coefficient. And remember that word coefficient, right? A coefficient is a number that's directly in front of a variable. We did that in number 3, the example right above here, where we had -5x. -5 is the coefficient. But what happens when it's a fraction? Like, what if we have 2/3 x equals 8? 2/3 x equals 8. Well, there's a couple different ways that we can interpret what to do here. All right. Now, just like number 3, when we had a coefficient in front of the variable, we did say that that is multiplication, right? We can think of 2/3 as a number, and that 2/3 is being multiplied by x. So to undo it, we could use the division property of equality, and we can divide both sides by 2/3. Okay, so divide by 2/3, divide by 2/3. And I did say earlier that whenever you're multiplying something by a number and dividing something by that same number, those numbers are going to cancel each other out. And I'm going to be left with x equals 8 divided by 2/3. Let me just write this down. Now, we don't really like to have fractions within fractions, so it's important that we simplify this as much as we possibly can. Remember, we could write it horizontally like this, 8 divided by 2/3. And if you remember back to when you learned about dividing by fractions, what you did was you changed the division to multiplication and you flipped the second fraction, right? So 8 divided by 2/3 became 8 times 3/2. Remember, we called that the multiplicative inverse. And then we can multiply straight across the tops and straight across the bottoms. And it turns out that x is equal to 24/2, or 24 divided by 2 is 12. So x is equal to 12. That's one way to interpret that. But that was a lot of work, wasn't it? First we had to divide, then we had to multiply. What if we just went directly from our equation, instead of dividing by 2/3, right? What if we picked up our equation down here where we switched it from dividing by 2/3 to multiplying by 3/2? Could we take our original equation, 2/3 x equals 8, and instead of, I'm going to slide this over, instead of dividing by 2/3, could we jump right to the part where we are multiplying by 3/2? So could I also multiply by the multiplicative inverse, right? Could I do that? Let's take a look and see. So can I multiply both sides by 3/2? Well, what happens when I get 3/2 times 2/3? I get 6/6. What's 6/6? 6/6 is 1, so I get 1x, which is the same as x. And then on the other side, I get 24/2 again, or x equals 12. It turns out that I get the same result if I multiply both sides by the multiplicative inverse right away. That saved me a lot of steps, didn't it? Look how much easier that was than dividing by 2/3 and then changing it to multiplication and then finding the solution. We could jump right to that solution just by multiplying by the multiplicative inverse in the first step. It would be great if you could give that a try if you ever encounter a fractional coefficient. So, in this lesson video, we took a look at how the 4 basic properties of equality were used to solve a one-step equation. We looked at the addition, subtraction, multiplication, and division properties of equality in examples 1 through 4. Remember, first identify which operations you see in the equation, and then think about the inverse operation to that and use that property of equality. Lastly, we looked at what to do if we have a fractional coefficient. If we have a fractional coefficient, then to undo the fractional multiplying by a fraction, we can multiply by the multiplicative inverse on both sides. So depending on which method you use, you may describe it if you divide by the original fraction, that's the division property of equality. But if you multiply by the multiplicative inverse, then you're using the multiplication property of equality. What's great about these properties of equality is that they tend to be quite fluid as you're solving an equation. You can think of addition or subtraction as being fluid, and you can think of multiplication and division as being fluid. All right, now it's your turn to practice. If you have any questions, please ask.